Hello everyone, welcome to another Quad Education Test Prep Fundamentals video. My name is Tom, and today I'm fulfilling my promise to go into a deeper dive on a topic that I said I'd talk about in our basic statistics video. So if you haven't seen that basic stats video, I would say go take a look just so you have all the background that you need. And the topic we're talking about today is averages. So averages are one of those things that I find people have a little bit of trouble on when the tests make the questions a little bit more difficult, and that's really a shame because averages are a really useful statistical metric. So without further ado, let's take a look. Okay, averages demystified. Quick recap, the average is the same thing as the mean, the arithmetic mean if you want to be specific, and you can calculate it by taking the sum of a set of numbers and then dividing by the number of numbers in that set. So if I had the numbers 1, 2, 3, 4, and 5 in a set, I would just add those all together, 1 plus 2 plus 3 plus 4 plus 5, and that sums to 15. And 1, 2, 3, 4, 5 is pretty clearly 5 numbers, and so 15 divided by 5 is 3. And so from that, we get this equation, A equals S over N. And so you may not have had that put into words like this before, so let me actually prove that to you. So I have a table here that gives the set of numbers. We have 1, 2, 3 different sets of numbers, and we have 3 properties for those numbers. We have the sum of the numbers, S, we have the number of numbers, N, and then we have the average of the numbers, A. So take a second to fill these in for yourself before I do, just to see if you can track this through. Okay, let's take a look. So sum of the numbers, 1 plus 2 plus 3 plus 4 plus 5, we already know that's 15. And then the second set, 3 plus 3 plus 3 plus 3 plus 3. Same thing as, I suppose, 3 times 5, because there's 5 threes, and that's also 15. And then here in the next one, we have negative 15, 0, 0, and 0. That totals to negative 15 so far. And then negative 15 plus 13 is the same thing as 30 minus 15, which is also 15. And then pretty clearly, there are 5 numbers in the first set. Then there are also pretty clearly 5 numbers in the second and in the third set, which is to say we have the sum of 15 divided by 5 gives us an average of 3 for all of them. And so hopefully this illustrates and proves that regardless of the specific values in the sets of numbers, when the sum of the numbers and the number of numbers are the same between 2 sets, the average of the numbers will also be the same. And you might be thinking, sure, Tom, fine, whatever, I show you this equation, and then you know full well you're just going to add the numbers all together and divide by the number of numbers like you always do and not do anything different or apply this equation. But we don't actually have specific numbers. Then we really can't do that. And that's absolutely something that you'll see on the test. And if we look at an example here, you'll see what I mean. So here I'm asking if a set of numbers or set A contains 4 numbers, and the sum of the numbers in set A is 20, what would the average be? And if you don't know what the numbers are and you're not doing it the way that you traditionally do, you can't really solve this. But if I show the proof here, hopefully I can illustrate that this is actually a better way of doing it. We have our average equals sum of our numbers divided by our number of numbers. They tell us that the sum is 20 and that the that the number of numbers is 4. And that's really, really straightforward because 20 divided by 4 is just 5. And so we don't need to add a whole bunch of stuff up. We just have the sum, have the number, and then we're done. And then what if it's even more complicated? So take a look at this one. So they're asking set X contains 3 numbers and set Y contains 6 numbers. The average of set X is 5 and the average of set Y is 12. What's the average of all 9 of the numbers? And so hopefully you didn't just say 5 plus 12 divided by 2 equals 8.5, because as I'll show here in a moment, that's not going to work. So let's show a little bit of proof. So I've typed out the proof here just because I don't want my bad handwriting to get in the way of my lesson. We're saying the average equals the sum over the number of numbers. And so that's fine. We've talked about that. And so what we have to do to get to the sum of the total of all the sets is we have to get the sum of set X and the sum of set Y. Because we can't just compare the averages because there's more numbers in set Y than there is in set X. So we know that the sum of set X is just going to be, we'll rearrange this equation to say that it's multiply both sides by n and say the sum is equal to the number of numbers times the average, which is basically a little sand there. So we know that the number of numbers in X is 3 and the average of the numbers is 5, and the number of numbers in Y is 6 and the average of those numbers is 12. And so then we're going to say that's 15 because 3 times 5 is 15, and 6 times 12 is 72, and we're going to divide all of that by 9 in order to get the average. And scrolling down a bit here, we can see that 15 plus 72 is 87, and 87 divided by 9, it looks like 9 2/3. And so when we find those totals that way and make sure we're dividing by the proper number of numbers, because again, we have 3 numbers in the first and 6 in the second, we have our new average. And that's really not that bad, I would say. And so I mentioned a couple of seconds ago, you can't just add those two numbers and divide by 2. And I sort of have talked about why that is, but like really specifically, why is that? Why can't we just add them together and divide by 2? Well, the answer is those two averages have different weights. Well, think about this. Think about if you were in a class and there were 5 tests in the class and you got 100%, so all the points on the first 4, 100%, 100%, 100%, 100%, and then for whatever reason you got a 0% on the final test. You wouldn't expect your grade to be 50%, like right in the middle of 100 and 0. Because there's so much more weight to the hundreds. It'd be much closer to 100. And the same thing is true of the example that I've shown here. You need to take into account the weighting of the averages. And so last little use case for averages here. Man, this is turning into a longer video than I expected. I guess there really is a lot of stuff that you can do with averages on these tests. And in this one, we're looking at changing the number of numbers within the set. So make sure to still use your a equals s over n equation here, and you should be fine. See what you can do. Okay, let's take a look, and hopefully my handwriting will be legible in this case. There are 7 numbers in set Z, so we're going to write a equals s over n. The average of set Z is 13, and the maximum value is 17. If the maximum value is subtracted from the set Z and replaced with the value 24, what is our new average going to be? That's interesting. Okay, so we know what our average is. It's 13, and we don't know what the sum is, but we do know that there are 7 numbers. And so we can solve for the sum. And so the sum is just 13 times 7, and 13 times 7 is 91. And then we basically are saying, okay, we're getting rid of the number 17 and we're being replaced by the number 24. And so if you like, you can just say minus 17 and then plus 24. But for me, that's basically just saying, you know, minus 17 plus 24. Same thing as 17 minus 24, which is just 7 more. And so if you're comfortable with that, I'm going to say, okay, we're going to add 7 to 91. And that's going to be 98. And now, since we have our new total and we have the same number of numbers, we can go ahead and calculate our new average, which is just going to be 98 divided by 7, which is going to be 14. And so even though we still don't know all the numbers in the set, we can still figure out the answer. Okay, moving on to our example problems now. There are 2 of these, but they're pretty large text, so we're just going to do one at a time. Try this one out and see what you can do. Okay, lots of letters in this one. So they're telling us the average of 12 exam scores is A when the highest score and the lowest score are removed from the 12 scores. The new average is B, which the following expresses the average of the highest score and the lowest score. That's really interesting. And so what we're supposed to do here is take our equation for the average, which is A equals s over n. And I suppose if you wanted to, you could call this a number. I'm not going to do that today because picking numbers for values is a video for another day, and that would be out of scope of this video. But we're going to do a little bit of letters as we calculate these averages, so bear with me. So our average here is just the letter A. And we don't know what the sum of the numbers is, but we know that the number of numbers is 12. And so hopefully for now, it's okay that we just say that the sum of the first set of numbers, let's do s on the left now. The sum of the first set of numbers is just 12a. And if you weren't sure if that was what you needed to do, I think taking a glance at the answers might help you with that, because there's a lot of 12a going on here. And so maybe we're supposed to think, okay, well, we know that the equation for doing an average is this, and then if we move them around a little bit, we end up with 12a. And so, yeah, we got 12a for our first one. And so what about our second average? So we're going to say that b for the second one is equal to that new sum. I suppose you call this s prime just to be a little specific. And then that's going to be how many numbers? Well, if we're getting rid of the highest and the lowest numbers, that's going to be 10 numbers. And so our second average is going to be 10b. All right, well, then what's the difference between A and B? Well, that is the highest and lowest score. So we want to find out what that is. You know, we're kind of getting distant from numbers itself here, but the difference between the first set and the second set is the highest and lowest score. So whatever that is, whatever 12a minus 10b is, regardless of what that actually is, those are those the highest and lowest scores. And so that's where we get our 12a minus 10b is equal to basically our, high score plus our low score. But we need to find the average of those two things. And since there's only two numbers, what we do is divide that by 2. And that's where D comes in as the answer. I'm a really big fan of that one just because it's getting to being a little bit immaterial, which is kind of what might make you uncomfortable. But if you're still applying the lessons that we've learned, it should be a reasonable expectation to get this one done. Okay, let's look at the second one. So what I've gone ahead and done here is made this a grid-in question. And also, just for the sake of being realistic, this would be an SAT non-calculator question. So if you can avoid using your calculator, I would go ahead and try to do that. Okay, let's take a look. How many liters of a 15% salt solution must be added to 120 liters of 5% salt solution to yield a 9% salt solution? So that is interesting. And so the first thing that we need to do here is turn this into math, because that's a lot of words and we are not doing words, we're doing math. So how many liters? So what I'm going to call that is X. The word of is going to mean multiply in this case. Usually when the word of by itself, that's a terrible asterisk. Usually the word of by itself in these tests is just going to mean multiply, just a good pro tip. 15% salt solution, I'm just going to express that as 0.15. So 0.15x must be added to 0.05 times 120 equals, and now here's a really tricky part, 0.09 times what we added plus the 120. So really interesting there. So next we'd say, all right, well, what can we figure out? Well, 0.15x, that's pretty fixed. And then we'd say, all right, what's 5% of 120? So 10% of 120 would just be 12, and half of that is just going to be 6. And then we're going to say, all right, well, what about the other side? So we have to distribute the 0.09, so we have 0.09x, and then we're going to do 9% of 120. So what's that going to be? Well, we just said that 10% of 120 would be 12, and then we could just take away 1% from that. So this is a lot of tricky mental math. That's minus 1.2, and that's going to leave us with 10.8. So 10.8, and next we're going to say 0.15x minus 0.09. We're just going to get our x's on one side. 15 minus 9 is 6, so that's 0.06. X equals, then we'll say, all right, then 10.8 minus 6, that's going to be 4.8. And you might think, oh dear, I got to divide by a decimal. That's no fun. But if you want to fix that, you can just multiply both sides by 100 pretty easily. And that's going to give us 6x equals 480. Yep, just making sure I got my zeros right there. And then also that's pretty straightforward because 48 divided by 6 is 8, so that's just going to be 80 for our answer there. So this is loosely an average question. What we're doing is basically taking the weighted average of the number of liters in the 15% and the number of liters in the 5%. And also selfishly, I just love this question. It was on an SAT, something very close to this a couple of years ago, and I just wanted to share it with you guys today. So hopefully you had as much fun on that as I did. Okay, that's it for this video. As you can see, there's a lot of really interesting and tricky things that the tests can do with the topic of averages. But if you're always sure to apply and write down the A equals S over N formula, you should be in pretty good shape. If you found this material useful, we hope that you will like and share the video and subscribe to Quad Education. Thank you for watching, and I hope you have a great day.